Hey, welcome back. Let's do a few extra problems finding volume. So let's say we have the function y equals x cubed, and our domains are given by x equals 0 to x equals 3 and y equals 0. And let's say we want to revolve this about the x-axis, and we want to find that resulting volume. So to solve something like this, of course, we're going to graph it. Now again, we're only interested in the first quadrant from 0 to 3. We know what cubic functions look like. They kind of look something like this. There we go. Now, you always have to find the domain. So that's what you also have to find the region. So you have to look at the domain that they give us. They want from x equals 0 to x equals 3 and y equals 0. So that's the x-axis. So which region contains all four of these constraints? And of course, the answer is this little region in between, and we can shade that in. Now, since we are going to revolve about the x-axis, we are going to have a vertical rectangle. That's nice because we don't have to switch our variables around, so that's kind of a good thing for us. So from the x-axis, I measure my rectangle of mathematics to the x-axis. So from my function to the x-axis. Remember, this is going to give us the radius for us. So let's see here. So this is going to be a solid disk. So I'm going to use my disk method. Remember, in a day or so we're going to talk about the washer method. So there's my disk, and from the center I'm going to draw my axis of revolution. That's the x-axis. This really does help. Since we're in terms of x, that's dx, and we just have to find our radius. The radius, remember, is the top function minus the bottom function. And the top is our x cubed. And the bottom is just 0. So x cubed minus 0, and I just get x cubed. So if I want to, so let's think about this real quickly. Let's see how easy this is. Once I got my rectangle, once I got my rectangles, watch, I can get my area pretty easy. Well, my area would just be my rectangle itself, which in this case would just be the radius. X, if I want to find the area, x cubed times the thickness dx, and that would go from 0 to 3. Well, that would give me my area of in between. Very easy to set up. What if I had a cross section? And let's say my cross section was an equilateral triangle. Well, my volume then would be the area of an equilateral triangle, which is root 3 over 4 times the base. The base here is my length of my radius. In this case, is that rectangle. X cubed squared dx, right? Don't forget, because times the height, and we would go from 0 to 3. That's how quick and easy these go. So now, so I got my area, I can get my cross section, and I can even get if I were to revolve this. So imagine we're revolving this. Like, what shape would you get? For me, it kind of looks like it'd be like almost like a gumdrop on it, or a Hershey's Kiss on its side there. So now, to get my volume of a cross with the disk method, volume by revolution, we would get our volume formula, pi r squared h. Remember, dh, that's just dx. The same thing here. My h is dx. My h is dx. So my volume would be pi times my radius, which we just said was x cubed squared dx. And I can simplify that. We would get pi. That becomes, we're going to multiply there, x to the 6 dx. And I can evaluate that from 0 to 3. And of course, if we were to solve this by hand, we would get pi x to the 7th over 7 from 0 to 3, which is just pi. I would just leave that there. 3 to the 7th over 7 minus 0. The AP would not expect you to know what 3 to the 7th is, so typically you can leave it like that. But simple ones like 3 squared, we would expect you to simplify those. So there we go. There is another example. Now, what if we have something like this? What if we have something like y equals, let's say, x squared, and our domain, let's say, is from y equals 0 to y equals, let's say, 2. And let's say x equals 0. And now we want to revolve it about the y-axis. Well, this becomes a little bit more trickier because if I were to graph this, let's take a look at the domain we're looking at. X squared, we know what that looks like. It's a parabola. Y equals 0, y equals 2, and x equals 0, which is the y-axis. So now our region is this little piece right in here. So this is a little bit trickier because we are going about the y-axis, which means we have to be vertical. So what do we have to do here? Switch our variables. Everything has to be in terms of y. So if I have y equals x squared, x would equal, remember, plus or minus root y, but we're in first quadrant, so we only want y anyways. So I draw my rectangle of mathematics in the first, from the function to the axis of revolution, which is my y-axis. There's my axis, there's my rectangle of mathematics, there's my radius. Okay, so if I were to draw it, this time my disk is going to be sideways, so it's going to be like a penny laying on its side. The skinny part would be dy. My radius would be which right here. There's my y-axis right here. The radius will be right minus left. So my right is the function. It's that parabola. Be careful, we're in terms of y. So root y minus 0. So my volume, because that's my left right over here, that would be 0. My volume, pi r squared h. Remember, this time h is dy because we're in terms of y. So my volume becomes pi r squared, which is going to be the square root of y squared dy, and we'd evaluate that from 0 to 2. Solving it, we get pi. This is just y right here, so I'm going to go and rewrite that if you want to. Y dy. Let's go and do this without a calculator. Pi, whoops, don't need that anymore. I'm going to integrate. Y squared over 2 from 0 to 2. Pi is a constant, so I can leave it out, and this just becomes 4 over 2 minus 0, or the area would just be 2 pi for us. Alright, so there's a couple more examples for you. Hope you guys enjoyed them. I will see you all later. Thank you.